Hi, I'm Elliot Kennel from the Cameron Group. I'd like to talk about how we will mass produce small modular nuclear reactors, which I believe are an important step towards achieving a carbon neutral society, a global society, which will require a lot of power in order to clean up the mess that we've made and to stop making new messes. It's not going to be easy. It's going to be very costly, and it's going to require international cooperation. Those are all very, very hard to achieve. This picture shows a possible layout of a small modular nuclear reactor from NuScale. It looks a lot different from nuclear power plants that we've seen before in the past. What is a carbon neutral global society? Well, it means that we're not increasing the carbon dioxide content in the atmosphere around the world, which is what we're doing today. Every year, the amount of carbon dioxide in the atmosphere increases year by year, slowly but surely, and we believe that is dangerous, that it's causing global warming. Um, that has to come to an end at some point, and we would even like to reduce the amount of carbon dioxide in the atmosphere. This is not going to happen overnight. It's not a crisis that we're going to solve in one or two presidential administrations. It's going to require the rest of the century to solve this problem. It's going to require a commitment. It's going to require collaboration from many nations, if not all of them, most of them, including the ones that have the most money, which would be the G20 nations. It's going to require a multiplicity of energy sources in order to make this work. Not just one, not just your favorite energy source, but everything that works: nuclear, solar, natural gas, petroleum, even coal, bio, and wind. All of these are going to have to be used where they fit in. Anything that works is going to have a role. Now, I caution that it's not a good idea to use these energy sources in ways that they don't work well. You have to find the places where they're best suited in order to work, not where they're worst suited. A classic case is, well, solar doesn't work well at night. Um, we also can't make carbon products unless we have fossil fuels. So nuclear is going to have to supplement those kinds of processes working together, not just one electric power source. A multiplicity is going to work best. And at the same time, we're going to learn to remove carbon from the atmosphere. It's an expensive process. Excuse me. We do know how to do it, but it's too expensive right now to be practical. But give us 75 years, and I think that, yeah, we'll probably be doing that, but it's going to be a significant cost. Now, what do we mean by modular? Well, what we mean is that we're going to make a plant. It doesn't have to be a power plant, but any kind of plant. We're going to make it in a module. That is something that's produced at one site, and then we're going to transport it somehow by barge, by rail, or by truck to the point of use. And then we're going to assemble these modules all together, and then voila, you have a plant. And if you make the same module over and over again at the production site, then you're going to get very good at it, and the price is going to come down a lot. It's the same principle that Henry Ford developed in 1903, that if you make the same product on an assembly line by mass production, the price comes way, way down. And that's been proven time and again by industry. Let's take a case study. More recently, or kind of recently, in circa 1948-49, there was a car called the Tucker Torpedo, which was the car of the future. And you might have seen a movie about this that was made a few years ago. But it was just an absolutely brilliant design. It had a rear-mounted engine, had a pop-out windshield, had an all-wheel independent suspension, disc brakes, and a directional headlight that would, if you wanted to turn left, that headlight would point left and show where you were going. And it was just really a wonderful, wonderful car. but it was very expensive, and Tucker sold 50 units and he had to quit. At the same time, just about, there was a car called a Volkswagen made in Germany in Wolfsburg, and it was a very simple car. Also had a rear-mounted engine, didn't have a radiator, it was air-cooled, didn't have a drive shaft, didn't have a lot of things, and it was small and kind of a rough engine, didn't go very fast. They only sold two in the United States in 1949. Boy, not very good. But they kept on selling, they kept on making these cars. And by the time they were done making them in 2003, they had sold 21.5 million cars worldwide. So let's think about that production line mentality and see how that might play into nuclear reactors. Another case study. This is a little bit different take. What about IBM OS2 versus Microsoft Windows? Um, Microsoft had come out with MS-DOS, and that worked on IBM machines. And IBM got the idea that, hey, we don't need this kid, Bill Gates. Let's take over that business and just kick him away. We don't need you, Bill Gates. And so, they have this really gloomy looking ad on the upper left about how great OS2 is. But, I guess the idea is that they're trying to make, I don't know, I guess these are doors that we're going to open with OS2, but it really looks kind of like I don't know, a haunted house or something. But anyway, so they're going to push away Microsoft. And in the meantime, Microsoft came out with a product that was more adept at utilizing the full features of the new 386 chip, whereas the IBM OS2 ran about the same on the 386 as the 286. It ran faster, but it was about the same performance on 286 as 386. And Microsoft just killed IBM on the marketplace. Now, it was not that it was a different media, like it was a different kind of floppy disk or something like that. It was the content, the media that was in Microsoft's favor. So let's think about that. The content was important, not really the media itself. And I don't know if you can see the caption I made there for Mr. Gates. It says, "This is looks like the cat that swallowed the entire canary." Okay, so what about the IBM? Actually, that should be the IBM 360. I beg your pardon, that's a typo there. It should be the IBM 360. That was really the computer of the 1970s versus Apple IIe, which came out in the 1980s and tried to compete. And there was, really no comparison. That IBM was more storage, faster, had much more software and computing ability. So obviously, it wasn't going to compete, would it? And also, the IBM machine was much more expensive, $2 million, and Apple IIe was $1,395. But today, IBM's market cap is 235 billion, and Apple's is 2.9 trillion dollars. So that's what we're talking about with mass production and an assembly line. All right, so what does these keys mean for nuclear power? The nuclear power industry needs to develop mass production processes and skills and not just reactor designs. I believe that artificial intelligence is going to be needed to simplify and guide the design of complex modules, make sure that they easily link together. And there are also going to be new methods to fabricate components as well as the modules themselves. That includes robotic welding, 3D printing, and also robotic machining to increase the reliability of each component and also to ensure the precision fit of components and modules. All of that is totally new compared to how nuclear reactors were built 20 years ago. The standardization of the components as well as the modules will greatly reduce the costs as you make more and more nuclear reactors. The U.S. needs a plan. This is also very, very important for end-of-life sequestration of radioactive waste. So I must be totally candid. I believe that the technology is there for how to store radioactive waste. I think we know what to do. But we have, I think there's a perception that if we can stop nuclear power, that that's going to result in great riches being showered on, our favorite energy technology, whatever that may be, whether it's solar, whether it's bio, or whether it's fossil fuel, whatever the favorite du jour is. The idea is that we're going to prevent nuclear from occurring by preventing the storage of radioactive waste long term, and that is not a good game to play. We know how to solve this problem. We need to have our leadership indeed implement that plan for end of life sequestration of radioactive waste. It has to be stored long term. There is no other choice. And I do think that it makes sense to build reactors now in this series production manner at the low end, at the Volkswagen end, let's say the 50 to 300 megawatt level. And then later on, I don't think that the small is so important as the modular aspect. I think you can make very large plants in modular fashion, but it makes sense to start at the smaller level first and then increase power later on as the technology matures. So what are we talking about robotic welding? What does that mean? Well, it means that, in fact, they have these robot welders that they use in the auto industry and many other industries, and they just make very, very reliable welds over and over again. And also they do robotic inspection. I didn't mention that, but they inspect the welds, make sure that they're good, that they're intact, that they're reliable, and that they're better welds than can be achieved by human welders. And that's very important for making any of these high-tech components. This is at the forefront of a new generation of joining technology, and it's very, very exciting. Also, I'm showing below a slide from Oak Ridge National Laboratories where they are actually using 3D printing to print certain components. These are components that hold together fuel assemblies shown below, and they 3D print these and also inspect them. They use artificial intelligence to guide the design of these components, and they are used in actual reactors, I understand, today. So this is not science fiction. This is not something that's going to happen in the distant future. It's something that they know how to do today. They're going to implement it, and it's really perfect for modular design, something that can be implemented on an assembly line today. And needless to say that the materials that are going to be used should be those that are well established and backed with extensive data. We have the ability to develop new materials and to put those on an assembly line if we want to, but I'm a bit squeamish about trying new things too fast. I want to do things that we already know how to do, and I would cast my vote for very reliable materials like, let's say, stainless steel, austenitic steels, and maybe Inconel, something like that. And I would like to operate at low temperatures that we're familiar with rather than push the technology too fast. I want to stay with what we know rather than extrapolate too quickly. All right, so the key takeaways: the small modular reactors are coming. I believe that this is going to be a very important growth area in the future, and it's going to be a long-term commitment. The arresting of CO2 emissions and ultimately the decrease of CO2 in the atmosphere is something that's going to be more of a process rather than an event. It's not going to happen overnight. If you elect the right presidential candidate next time, that's not going to solve the problem. It's going to take many uh, presidential administrations to bring that down. Success depends on a commitment to the modular assembly process and the implementation of new technologies on the modular assembly lines, including artificial intelligence, simplification of the modules themselves, as well as the parts and integration. And some of the key things that I think are going to be great investments for the future are robotic welding, 3D printing, inspection. I didn't mention here on this slide, but also then the total life cycle of the reactor and components, including the fuel cycle and the ultimate sequestration of radioactivity and especially the fuel. So that's what I think is going to happen. That's what I think should happen. I am an advocate of this technology. I think it will make a meaningful impact in the lives of us, right now, soon, and also our children and grandchildren and great grandchildren. They're going to be the ones that actually implement this, and they will live to see a time when the CO2 levels are decreasing globally rather than increasing. So that's what I've got. I'd be delighted to hear from your comments. If you can, if you like what you see, give me a like and also comment below. Thank you very much. God bless you all. Bye bye.